Okay, this is the Algebra 1 Unit 7 video. I explained this in a classroom post, but this is counting for Unit 7. But when you go into Buzz, you'll be working on Unit 6 of the new curriculum. But this is the second unit we've done in this class together. So it is technically Unit 6 in the curriculum, but for us, it's counting as sort of our 7th unit. So I'll figure out the best way to explain that in the description. But this is Algebra 1, Unit 6, Lesson 1. And this whole unit is all about what we call systems of linear equations. And when we talk about systems of linear equations, we should probably kind of talk about what that means. And when we talk about a system of linear equations, we're talking about two or more linear equations that we are trying to find out how they are related to each other. So remember, linear equations are equations that are generally thought of in this slope-intercept form. And a system means there's more than one. So you're going to get a set of two. So it could be something like this: y equals 3x plus 2, y equals 1/2 x minus 7, whatever. So this would be a system of linear equations. And so before we get into the detail of this, I want to talk about just some basic ideas around this. So they're going to be wanting us to find the solutions to these systems. So what we're dealing with is three possible outcomes. So let's say these are my coordinate planes for three different situations. And in each of these, I'm going to be showing what it would look like for a system of equations to be graphed. So remember, a linear equation graph is a straight line. So if I graph two straight lines, there's three ways that they can be related, right? One, the most obvious, is that they just cross somewhere on the graph. So this right here would be the solution. So the solution takes the form of an x, y coordinate. So that's one possibility, okay, is that there is a solution. Another possibility is that those lines are what we call, that would be one solution, is that what they're called sorry, I'm having trouble writing today. Inconsistent. Inconsistent means there are no solutions because these two lines do not intersect. There is no point where they intersect. So there are no solutions to that. Lastly, they could be, it's hard to illustrate this, but they could be the same line, right? Kind of try to illustrate that. This is what we call coincident because they coincide. They are the same line. And so we say that there is infinite solutions because those two lines intersect in a sense at every point on the graph. So whereas this has one solution, there's one place, and we call that consistent. The middle one has no solutions, so it is inconsistent. There's nowhere where those cross. Coincident means the lines overlap completely, meaning that there is an infinite number of solutions. So I'm going to jump back over to our lesson, and I've kind of gone through these different things. I've talked about coincide, consistent system, inconsistent system, right? Independent means that there is exactly one solution. Dependent system means there's an infinite number of solutions. So dependent and coincide go together. Consistent and independent go together. And then inconsistent is kind of its own thing. We talked about what an intersection is. Remember, an intersection is a place where the lines cross. And then the solution is the intersection. And then we talked about what a system of linear equations is. So let's talk about how we're actually going to solve these. I'm going to kind of skip down a little bit. So there's another example of the three possibilities that I talked about. We have consistent and independent, we have inconsistent, and we have consistent and dependent. So make sure you kind of just pay attention to those terms. So in the lesson, there's a nice little helpful table to talk about what those look like. So we got some vocab here at the top. Two lines in a linear system, blank, they have exactly one point in common. That means that they intersect. And you just need to use the terms at the top to answer the questions you have here for number 1, 2, 3, 4, 5. So you got a bunch of vocab. I think there are exactly 7 vocabulary questions, so those should be pretty easy for you to get. So just use the bold-faced words at the top for those. Then we get into the actual problems. Match the graph with the correct set of equations for the linear system. Then classify the system as dependent or consistent and dependent, consistent and independent, or inconsistent. So it's 3 options: consistent and dependent, consistent and independent, inconsistent. Okay, so those are your 3 options. So we're going to basically start with, I think, what is the easiest part of this, which is that just by looking at this graph, I already know which of those 3 options it is. I may not know the equations, but I definitely know which one of the 3 options it is. So it is consistent because consistent lines intersect or touch. This way of drawing it, I know I drew it differently on mine, but if you look up here, this way of drawing it was their example of coincide. And if you look here, coincide says consistent and dependent. So what you need to do is you need to take the graph that they give you. You see they've got multiple examples, and you decide which of the graphs from above, and I will post that in the notes, which of the graphs of the above does it look like. So this one looks like consistent and dependent. Okay, again, I'm getting that from this little 3 chart figure right here, because it looks like coincide, consistent and dependent. All right, that's how I got that. So then that's the easy part. But then the question is, how do I know which one of these equations it is? So this is where we're going to use our graphing utility. We're going to use Desmos, and I'm going to type these 2 equations in and see if it looks like that. So let's go to graphing. First one, I have 4x plus 2y equals 6. 4x plus 2y equals 6. I'm just going to bring up there it is. Okay. And then the other one is 4y equals, but I'll be honest, I can already tell by the look of it that it doesn't work. Plus 4. Okay. So you can see right away, these lines don't look like this line. They don't go across the graph in the same way. Also, they're not the same. They're parallel. So clearly that one's not the answer. Thankfully, I'll give you a little hint, the answer choices for all of these questions are the same. So you should go ahead and take this opportunity to say, well, which one of these questions does this graph apply to? And I can tell you right now, it applies to number 10. I can see these 2 lines match the graph that I have right here. You don't have to be that detailed about it. It's pretty clear. They cross at about the same places on the graph. So then we would be choosing that answer choice for number 10. So use that to your advantage. You won't have to graph these over and over again. You can just graph it once and then find the question that it goes with. So let's move on to the next one. So we know that's not the answer. So we go x plus y equals 0. X plus y equals 0. Whoa, oops, there we go. X plus y equals 0, and negative x plus y equals negative 8. Again, doesn't match the graph that I have here. However, it does match the graph I have in number 9. So that's very convenient. So I'll just choose that one down there. I'll let you do the other half of these questions. Sorry, I kind of already explained those. So let's just graph the last one just for the sake of argument. 3x minus 3y. 3x minus 3y equals 6. And negative x plus y equals negative 2. And we can see the purple and the black are the same graph. And you can see the graphing system struggled to find an intersection point because it intersects at so many places on the graph. So you can see that kind of plays out here with all these different points that they found that were intersection points. So that's just kind of a good example of how that happens often. So these are the same line. So then that would be the answer for the graph. So you need to choose two answers. You need to choose one of the statements or one of the names and then one of the sets of equations. So that should get you through number 9, through number 10. Number 11, use the graph to solve the system of equations. Not much to say here except you know the system of equations solution is the place where they intersect. So you just need to find which one of these corresponds with this point. Remember, the points are in the form x, comma, y. So x coordinate comes first. Remember that. Same thing with number 12. You need to find the intersection point and find the solution. Now, this one's a little bit different, but it says you're working with your friend who finds a solution for this equation, and you need to explain why it's incorrect. So they're saying these are the lines, and that's where they intersect, and we're saying, well, that isn't right. Well, we're going to just graph these lines. Negative x plus 2y equals 1. And negative 2x minus 3y equals negative 12. Negative 2x minus 3y equals 12. Right? Negative 12. Negative 12. All right. So first, right off the bat, I see they've graphed these lines incorrectly. Specifically, they graphed the blue line incorrectly. So this line, I think the red one, is graphed correctly. It crosses at negative 1. It crosses at 0.5. That's what I see here and here. So this line, negative x plus 2y equals 1, is graphed correctly, but it's this other line that's not graphed correctly. It says your friend has the slopes correct for both lines, but not the y-intercepts. Well, I can see, yeah, the slope is the same for the blue line as it is here, but the y-intercept is different. The y-intercept here does not match the y-intercept of the blue line here. So that is going to be the reason the friend has the incorrect answer. So really on this question and in the ones on the quiz, you just need to see what is wrong about the graph. What did they make a mistake on? All right. And that's the end for this lesson. Oh, actually, I want to do one more thing. Let me jump to the next lesson because the next lesson is a continuation of lesson 1. There is a set of problems here. It will have you download. And you can see there's some systems of equations that you need to do. I need to see from you, please, a screenshot of at least one page. So maybe these first 2 questions would be enough for me. So show me that you know how to graph these. So what I would really be looking for would be for you to graph these equations on Desmos and show me what the graph is that you got. So what I'm telling you is for this worksheet, you just need to send me screenshots of the graphs that you found with the solution. So like on this one, I would send an image like this that shows the equations and shows the solution with you clicking on it. So that's pretty much how that one will go. So send me at least a couple of those. I'm not going to check the entire worksheet, but it will also give you the answers so you can check those yourself.